For section 6.1, what we want to talk about is going to be the area between curves. If we look at this first graph, we see that f of x is going to be a curve on top of g of x, which is going to be another curve. And we want to ask, okay, what's the area between the two curves between a and b? To find the area, consider the area of f of x and the area of g of x. And if we want to find the area in between, well, take the area of f of x minus the area of g of x. And that is going to give us the whole idea of 6.1. Now let's take an example. Usually when you want to solve this kind of problem, given a problem like this, find the area of the region enclosed by x squared and 2x minus x squared. For this kind of problem, what you want to do is first sketch a graph so that you can get some sense of which function is on top and which function is on the bottom. The graph of y is equal to x squared is just going to be a parabola, something that we all know. The graph of the second equation, y is equal to 2x minus x squared, is going to be some parabola that's going to open downward. And this is how the graph should look. And the question amounts to asking, what is this area? So we can see that the top function, or the top curve, is y is equal to 2x minus x squared. And the bottom function is going to be y is equal to x squared. So now we want to set up the integral knowing what function is on top, what function is on the bottom. The integral is going to be the top function minus the bottom function. And there we go. Now we just need to solve this. But before we solve that, we have to know what are the upper and the lower limit of integration. The lower and the upper limit of integration is precisely the point where the two graphs intersect. Meaning this point right there at 0, 0, and whatever that point might be at, let's say, x1, y1. Actually, we only need the x1. We don't even care about the y unless we are working in some function that's been defined in terms of x. in terms of y. Let's try to find x1. Well, x1 is going to be the location where the two functions intersect. So what we want to do is, well, let the function be equal to one another. Move everything to one side. Factor. Solve. So we see that precisely at this point, x1 is equal to 1. So our limit of integration goes from the first point where they intersect to the next point where they intersect, meaning this function is actually equal to the limit from 0 to 1 of the top function minus the bottom function. And that's what we want to solve. So we just solve this. That's going to be from 0 to 1. Sorry, that's not it. Now we just integrate. Integrating the first term gives us just x squared. Integrating the second term gives us 2 over 3 x cubed. And we are going to evaluate this from 0 to 1. Plug in 1. If we plug in 0, we don't get anything, so we just leave that alone. 1 minus 2/3 is going to be 1/3. And that is going to be the solution. Now, one more thing that I want to note about this is that note sometimes the function changes which one is on top and which one is on the bottom. For example, in this example, we see that the blue curve go underneath the red curve up into A, become the top curve between A and B, and then go below the red curve again, starting from starting from B. So the area for this, let's say that the red curve is going to be given by the name f of x. The blue curve is going to be given by the name g of x. So the area for this is going to be the integral from 0 to a. Which one is going to be the top curve? Well, that's going to be f of x minus g of x plus the integral from a to b. This is where the curve changes position, meaning it's now g of x minus f of x. And then finally, the last one from B to C, it changes position again. So now it becomes f of x minus g of x. An example of this is posted on Moodle, so you can look at that. Just be careful that sometimes the curve might change position.